All right, this question asks us to predict predict the substitution products of this particular reaction. And then it asks us the question, would this be SN1 or SN2? Well, what we want to notice is that the leaving group is in a tertiary position, and the thing that's going to act as a nucleophile in the substitution reaction isn't a particularly strong nucleophile, it's methanol. So in order to consider what's going to happen with these two facts, we would say that a tertiary carbocation is going to be pretty stable. And in the absence of a strong nucleophile, it's going to have time to form before anything else happens. And so we're starting to think about SN1. So we're going to say the leaving group's going to leave first, which would form a tertiary cation. But take a look at this cation it forms. It's tertiary, but it's also allylic. And so that means there's going to be a resonance structure that forms that shows me where these pi electrons can delocalize and the positive charge can move down into the ring. So what does this mean then? This means there's actually going to be 4 possible products. Because the carbocations are planar, that means that the nucleophile can attack from both sides. So in each carbocation, there's going to be 2 possible structures. Now, the structure with the cation that's allylic and tertiary, that's going to lead to the major products because that's more stable than allylic and secondary, which is the one at the bottom. But they're all 4 going to be present. So let's consider all 4. So the first one leads to a structure that looks like this. And so the only difference between these 2 structures is going to be where the nucleophile gets attached, whether it's coming towards us in a wedge or going away from us in a dash. And we'll put that on there in a second. The same thing is happening below. I'm going to have the only difference being the direction that the methanol gets attached. So let's go ahead and do that now. So in one case, I'll have the methanol attach there. This would be a hydrogen. And in the other case, the methanol would attach there, and that would be a hydrogen. So the same thing is happening here. I'm going to have the methanol in different locations. Now, again, this one is major. This set is minor, but in each of the major and minor cases, I should get an essentially 50-50 racemic mixture. And again, this happened via an SN1 reaction.